Question 5a. The sketch shows the graph of the curve y equals f of x, where f of x equals 2 times inverse cos of x over 3. The area under the curve for x greater than or equal to 0 and less than or equal to 3 is shaded. Part 1. Find the y-intercept. To find the y-intercept, we substitute x equals 0 into the equation. So the y-intercept is equal to f of 0, which is equal to 2 inverse cos of 0 over 3, which equals pi. Part 2. Determine the inverse function y equals inverse f of x and write down the domain D of this inverse function. To make the process of finding the inverse function a little easier, I'm going to rewrite the original function with y on the left-hand side rather than f of x. So I'm going to replace f of x with y, and the original function can be written as y equals 2 times inverse cos of x over 3. The next step is to swap the x and y variables around and then make y the subject of the formula. So we have x equals 2 times inverse cos of y over 3. Dividing both sides of the equation by 2, we have x over 2 is equal to inverse cos of y over 3. Now we want the side of the equation that has the y variable on the left-hand side. So swapping both sides of this equation around, we have inverse cos of y over 3 is equal to x over 2. Taking the cos of both sides of this equation, we have y over 3 is equal to cos of x over 2. And then multiplying both sides of this equation by 3 and replacing y with f inverse of x, we have f inverse of x is equal to 3 times cos of x over 2. Now, the domain of f inverse of x is equal to the range of f of x. And the range of f of x equals 2 inverse cos of x over 3 is y greater than or equal to 0 and less than or equal to 2 pi. Therefore, the domain of f inverse of x is x greater than or equal to 0 and less than or equal to 2 pi. Part 3. Calculate the area of the shaded region. The area of the shaded region can be found by integrating with respect to the x-axis. That is, the area of the shaded region is equal to the integral of 2 times inverse cos of x over 3 from x equals 0 to x equals 3. Now the problem we have here is that integrating a function of this type, which contains an inverse trigonometric function, is relatively difficult. We could make it a little bit easier by integrating the inverse of this function and using as limits 0 and pi. So the integral from x equals 0 to x equals 3 of 2 times inverse cos of x over 3 dx is equal to the integral from x equals 0 to x equals pi of 3 cos of x over 2 dx, and this is from part 2. So the integral of this is equal to 6 times sine of x over 2 from x equals 0 to x equals pi. So applying the limits of integration, we have 6 times sine of pi over 2 minus sine of 0. And sine of pi over 2 is equal to 1, and sine of 0 is equal to 0, and that equals to 6 square units.